In this project, we are going to create an app with which the users can store notes. So the users will be able to take notes using this app. In this app, we'll be utilizing Room, Livedata, and ViewModel, and also we'll be creating some repository classes to store the data sources, okay, to maintain the data sources. So let's get started. So create a new project, select empty activity, click next. Let's name it as notes. Okay, change the package name if needed and save location and language, keep it as Kotlin because we are going to create this in Kotlin. Click finish. First thing first, so let's add the dependencies in the Gradle files. So for that, go to the module level Gradle file and let's first add the cap plugin, which is nothing but the Kotlin annotation processing tool. And just make sure that you have JVM target 1.8 here. Let's add all the dependencies for Room, ViewModels, and Livedata. So for that, I am replacing the dependencies with this new set of dependencies. So it has the Room lifecycle, which has the ViewModel Livedata dependencies. And then we have some dependencies for the coroutines UI and the testing ones. Okay. And here we are taking the versions. So this version has to be defined. So to define the versions, go to the project Gradle file and add here an XT. So here you can specify all the versions. Just make sure that you give the latest versions here for each of these components. Also add the Kotlin version here. Okay. So now try to sync it. Okay. So the Gradle sync is now finished. So now we have added all the dependencies. What we have done is we just added the dependencies of all these modules here. Also we added the Kotlin cap, which is the annotation processor for Kotlin. And then in the build.gradle, we add the Kotlin version and also added these version numbers. So we have to basically update the latest version number here. To get the latest version numbers, you can go to the Android X releases and here you will get the list of all the components and you can take the latest version from here. It's recommended to take the latest stable release. Okay, so we need to store the notes in a table in SQLite. So for that, we had to first create an entity or a table in notes. So we have to instruct Room to create a table or an entity in SQLite database. So in case if you don't know what an entity is coming from the database world. So entity is nothing but the real world object. Okay, so that's the definition of that. So real world objects in our case is the notes. So we are creating an app to store the notes. So now we are going to create an entity or a table where we could store the notes. Okay, so let's create that. So to instruct Room to create an entity, we need to first create a data class. Let's name it as note. Okay, I'm just replacing this. So this is a data class where we instruct Room to create a table named note table with two columns, one primary key and another column. Okay, so the primary key is nothing but the unique identification number for our note. Okay, so primary key is nothing but a unique key and that is auto generated in this case, and the column info is nothing but the column name where we will be storing our notes. Okay, so we use this entity annotation tell Room to create a table. So whenever we add this annotation, it tells Room to create a table named this one, note table, in the SQLite database. Okay, so let's import these missing imports. So you can see the entity is coming from the Room library. Okay, let's import primary key and column in. Okay, so this is what we need to do to create a table in SQLite. So to summarize, entity is nothing but the real world object. Okay, in our case, the real world object is the notes. So we are going to create a notes table in SQLite, and for that we are instructing Room to create a table with this structure. So here we are saying to Room to create a table named note_table, which is having two columns. The first one is a primary key. So primary key is nothing but a unique identification key and it's auto generated. That means it will be sequentially created like 1, 2, 3, 4. So if you have 10 notes, there will be 10 IDs. Okay, and this is integer value, and then the note itself where we store the actual notes, and that is a string value. Now let's create the DAO or data access object for our notes table. So DAO is nothing but an interface to the database. So the DAO helps us to access the database. So in this case, the DAO which we are going to create acts as an API or an interface to the nodes table. So we'll be creating the APIs for three things. One, to insert the data, delete the data, and get all the data from the nodes table. So in Room, we could create DAO using an interface or an abstract class. So let's see how we can create that. So to create the DAO, we have to create a new Kotlin class, select interface, and let's name it as node DAO. I'm replacing it with this. Okay, so here we are instructing that it's a DAO object. So let's import this. So this is again coming from Room. So we are saying that this is a DAO object and we are mapping the methods to the SQL queries. So let's import these. Okay, so here we are mapping the method with the query. Okay, so on top we have the SQL query. So this says to select star means everything from nodes table and order it by the node field in ascending order. So this will basically order the data which is returned in ascending order. So alphabetically in the ascending order. And the method is get alphabetized nodes. So, and this will return a list of node. So this will basically contain all the data from the node table. So here we are mapping these two things together. So this query will be mapped to get alphabetized nodes. So whenever our app uses this method, internally SQLite will be running this query and returning the data, and Room will basically return this list back to us with the alphabetized nodes. And then in the second one, we are creating an insert query. Okay, so in case of insert, so we are saying to ignore a conflict. Like in case if it already exists or something like that, then just in case of a conflict, just ignore it. So in case of a conflict of data, just ignore it. Okay, so in the insert, we are simply inserting the nodes. Okay, so we will be passing the nodes and it will be automatically generating an insert query. So the actual insert query will be like insert into nodes table with the data. Okay, so only thing we have to define here is to ignore the conflicts. And then finally to delete the data. So to delete everything from the data, we are using delete from nodes table. So this will delete blindly everything from the nodes table, and this is binded to delete all method. Okay, so it's pretty straightforward. And here you can see the @DAO annotation, and this says that this is a data access object, and Room will have to bind these two things together so that whenever the app calls this method, it executes these SQL queries internally. Okay, so to summarize, for DAO we have to either use an interface or an abstract class, and we'll have to annotate it with @DAO, and then we have to bind the queries with the methods. So to select the data, we use @query and we give the select queries here and bind it to the corresponding method. Similarly, in the insert, we bind it to the insert method, and in this case we only mention that there is in case of a conflict, just ignore it. Okay, and then and the last one, to delete the data, we are just binding delete all to delete from nodes table. Okay, so we are now done with the node DAO. So the app has to observe the data in the database, and whenever the data in the database changes, it has to update the UI. So that means we have to constantly observe the data within the database. So for that, we will use Flow from Kotlin coroutines. So the Flow API in Kotlin is basically a better way to handle the stream of data. So in our case, we are getting a stream of data from the nodes table, right? So Flow API is just a better way to handle this stream of data and to observe them continuously. In the later sessions, we will convert this flow into a live data that we will do within the view model. So for now, what we need to do is we simply need to wrap this list with a flow. So to use the flow API, we have to just wrap this list with flow and just import this. So that comes from the Kotlin coroutines. So using a return value of type flow in your method description tells Room to generate all the necessary code to update the flow whenever there is an update in the database. So this will basically tell Room to generate all the code needed to update the observer whenever the data changes in the database. Now let's create the Room database. So the Room database has to be an abstract class which extends the Room database class. So let's create it first and then we'll discuss about it. Okay, our Room database is not Room database. We create a class. Okay, and let's replace this with our actual class. So as you could see here, the not Room database extends Room database and it's also an abstract class. So these are two basic requirements when you define a Room database. Okay, and also you have to annotate the database with @database notation, and within the brackets you have to give the entities, which are the tables you have already defined. The not table we have already defined here, so that has to be added here. If you have multiple tables, you have to add those tables here. And this is the version number, so whenever you upgrade the database you have to change this version number as well. And then export schema false. So we are setting the export schema false as we are not planning to export this database. So in case if you want to export the schema, you have to set this to true. For this example, we are setting it to false. One more thing to note here is that it has to expose all the DAOs which you have created. The DAO for the node we already created, right, where we binded the SQL queries to these methods. So that has to be exposed here, all the DAOs. So in case if this database has 2 tables or 3 tables, so all the DAO has to be exposed here, and the tables has to be also added in the entities list. Okay, and then we have a singleton instance returned from this class. So here you can see we have a companion object, and within the companion object we have this instance, and there we have the get database method or function. So this will return always a single instance of this database. So at any point in time there shouldn't be multiple instances of the database object for the app. What we are doing is we are just using the Room database builder method to build the database, and we are setting the name to not_database, and the class name is set as not Room database class. We are also passing in the application context here. So we are basically building the instance of database here, and that instance is assigned to this instance variable which we created, and we are returning that instance here. So you could see that we are returning that instance here. So it will always create only one instance of the database. By using Room, we have some advantages, like for example these select statements, right? It will catch the syntax errors with the SQL queries. So for example, if you give something like this, it's not a valid SQL statement, so it will be catched during the compile time itself. Okay, so for example, if I just change from to FRO, then you get the message compound operator from group limit or where, so it's FRO is not acceptable. Okay, and now we have seen how to create a Room database. To summarize, all the Room database has to be annotated with @database annotation, and all the tables or the entities has to be given here, and these entities we already declared here. This is basically the structure of the table. So in our case there is only one table to store the node. We have already defined here with this structure with the primary key and column, so that has to be passed under the entities, and then the version number. In this case, this is the first time, so it's 1. So whenever you upgrade the database, you have to give it 2 or 3. Okay, and then export schema, we are setting it to false. So the basic purpose of export schema is to export this schema and store it somewhere in the repository so that you can have a look at the structure of the schema or the database. So we are not doing that now, so that's why we are setting it to false. And then Room database, the two most important thing is that it should be always an abstract class, and it has to extend the Room database, okay, class. And then so we have to expose all the DAOs. So expose all the DAOs. So if you have multiple DAOs, in our case we have only one DAO which we created. with the SQL queries and the methods. So if you have multiple DAOs, you have to expose it here. Okay, and then we have the companion object, which is a singleton. So within that we have this method which will return a singleton instance of the database, and the database we are creating using the room.database builder, and we name the database as not database and passes these two parameters, the context and the not room database class, to build it. Okay, so and we return this instance. So it is guaranteed that it will be always a single instance. So at any point of time, there will be only one instance of the database. So now let's go ahead and create the repository class. So the repository class, as we discussed earlier, is not part of the architectural components library. It's just an abstraction to the data sources of the app. So for example, one app could have multiple data sources. So in this particular case, we have the SQLite as the data source. Normally in the real world applications, will have multiple data sources. So for example, the SQLite, and another data source could be the Firebase, which is a cloud-based database. So the repository class basically abstracts that. That means it provides a clean API for accessing all of these data sources. Okay, so let's go ahead and create that one. So for that, create a node repository class. Okay, replace it. Okay, we are creating the node repository class here, and we are passing in the node DAO. So the node DAO, the DAO class which we have created earlier, the node DAO is sufficient to access the database. We don't need to actually pass the database itself here. Okay, so we could use this node DAO object to access our node database. So as you could see, there is a get property which is all nodes. So this will return all the nodes from the database. It uses the node DAO dot get alphabetized nodes. So we have defined this earlier in the node DAO, which will in turn executes the select star from node table order by node ascending. So this will return a float type back to this all nodes property. And then we have an insert method. Okay, so the insert method will basically insert a node. So there it has a parameter node, and this node is nothing but this entity or the table which we created. So we had to pass in as this object, and then that will go ahead and call the node DAO insert. So the insert will insert the data into the SQLite database. So it will be executing an insert statement internally into node table with all these values which we are passing. And this is a suspend function. By default, this will be running in a separate thread, not in the main UI thread. So the @worker thread, this is to emphasize that this method will take more time, or it's going to run a heavy duty statement. So it's just to show that. Okay, so even if you remove that, this app should work fine. To summarize, the node repository has one get property, all nodes, which will return all the nodes. There is an insert method which will insert the node into the database. Now let's create the ViewModel class. So as we discussed earlier, the basic purpose of ViewModel is to provide the data to the UI. Okay, so the ViewModel basically will convert the flow data into the live data and pass it on to its observers. So the observers will be the UI components. So let's first create the class. Model, let's replace it. Okay, so the node view model passes in the node repository. Okay, and with this repository object, we call the insert and get all nodes. Here you can see that the view model classes will extend view model. So this is coming from Android X lifecycle view model class. So all the view models should extend the view model class from the lifecycle component. And here we could see there is a property which actually returns a live data. Okay, so here we are calling the repository dot all nodes. So the all nodes basically returns a flow, and within the view model we could see that it's getting converted into a live data. So this gets converted into a live data and it passes on to this all nodes property. Okay, and this will be further utilized for the by the components. Okay, and here you can see the insert method or function, and the insert function starts within a view model scope. Okay, and then it calls the insert method from the repository. Okay, so this is done such that it doesn't block the main thread. Okay, so it calls in a separate thread, and that's the purpose of ViewModels scope.launch. So we'll cover this in detail when we look at the coroutines. Okay, and then we also have a not view model factory. Okay, and the purpose of this is to return the not view model. So this basically returns an object of this view model. Now quickly summarize. The not view model extends the view model, and it also passes the not repository which we created earlier. And the all nodes get property. This will basically convert the flow coming from this method to a live data. We have the insert function. This will launch a new coroutine. This view model scope.launch will launch a new coroutine scope, execute this insert statement. View model factory, which actually returns the object of the not view model. Okay, and the framework, the Android framework uses both these classes to make sure that the corresponding UI survives the state changes. Now let's work on the UI part. So basically in the UI we need a recycler view and a button to add the nodes. So let's first update or add the resources file. So for that, go to resources, layouts, activity main. So at the moment it has only this text view, right? So just go here and just replace the text view. We don't need text, and we will add one recycler view and one floating action button. Okay, so the floating action button will be here, and the recycler view is basically the list which will show our nodes. Okay, so we have to add these. So add node. Okay, so we have added a string add node. So this will be displayed in the button, and then we need to have the list item, recycler view item. We will add this shortly. And now let's add the recycler view item. Okay, so the recycler view item is nothing but one single element within the recycler view. So to add that, let's add a new layout resource file, name it as recycler item. Click OK. Okay, replace it with the linear layout. Now come back here. So now you could see this the recycler view item. Okay, so now all looks good, and the background color is orange light. That's why it's orange. Okay, now let's create the not list adapter for the recycler view, and then add the recycler view itself to the main activity. Okay, so for creating the list adapter, create a new Kotlin class, not list, replace it, just thing. Okay, so here is the not list adapter. So the basic purpose of this class is to bind the data to this item. So we have this one element here, right? So in the activity main, in the recycler view, we have multiple elements of recycler view item. So the basic purpose of the list adapter is to bind the data to this recycler view, to bind the data to each of the elements of this recycler view. Okay, so we are not getting deeper into recycler view. The concept is very simple for recycler view. So you have this list and we have an adapter, and the adapter will bind the data to this recycler view list. Here you can see the not list adapter extends this list adapter class, and it takes these parameters. It is defining two methods, on create view holder and on bind view holder. Okay, and it also has two classes, not view holder. So this view holder basically binds the data to that one single element. So here you can see within the view holder we create not item view. It's referring to the text view of this element. So this text view element which we created earlier. Okay, so in the not list adapter, this class not view holder actually binds the text to that text item which we have defined earlier, and it also has a companion object which inflates the recycler view item. So the recycler view item is this single item. Okay, and it also has a nodes comparator. So this is basically to compare the new and old values. So this is being used internally by the recycler view. The list adapter has on create view holder method, which is triggered when the view holder is created, and here not view holder is created. So this object is created here, and this is getting passed as holder to the on bind view holder, and here you can see it's calling the on holder dot bind, which is this method. So this will bind the text to the text view, which we have declared here. So it will bind the data to this text view. So if you find this complicated, please have a look at the recycler view. To just summarize, so we have already defined the recycler view item. So there's a single item, and the recycler view is defined here. And this recycler view needs an adapter which can bind the data to that recycler view, and that is done here. The not list adapter, and this not list adapter has two methods: on create view holder and on bind view holder. And in the on create view holder, we instantiate the not view holder, which we have defined here. Okay, so this is extending the recycler view holder. This has already a bind method which will bind the text to the text view. So that is the instance is created here, and that is passed to on bind view holder. And in the on bind view holder, we are calling this bind method, which will actually bind the text. So the concept is pretty simple. If you are confused, have a look at the recycler view documentation. Now let's add the recycler view in the on create method of the main activity. On create method of the main activity. For that, go to the main activity. So here we are first getting a reference, this one, and then the adapter which we created just now, the not list adapter, that, and then setting the view adapter to this adapter. So here we are basically binding view and the adapter. Okay, so the adapter's responsibility is to take the data and bind each elements in the recycler view. Okay, and then we are in layout manager in this. So let's rebuild the project once again. Okay, and run it. Okay, so yeah, it was expected, so it's running without any errors, but we have more to do. We haven't initialized the repository or the database yet, so we have to initialize the database and repository, and then also add some dummy data to the database.